This is a somewhat recent acquisition to my collection. It is a 750 watt self-ballasted mercury reflector lamp made by Iwasaki, as you can tell by the eye mark on it. Japan. This was made in Saitama Ward of Tokyo. And December 2013, which is quite recent for these things. This is a 240 to 250 volt lamp. R57 envelope, so it's a big mother. Most likely intended for the Australian market because the packaging did have an EAN or European article number format barcode instead of the UPC or Universal Product Code format barcode that we have over here. Very easy way is to tell by the number of digits under it. If it's one digit, then six digits, it's EAN. If it's one digit, then 5 digits, then 5, then 1, it's UPC, or Universal Product Code. And there's the inside of it. Filament, discharge tube, which is just a conventional, probably 400 watt high pressure mercury discharge tube. And it's ballasting filament. That ceramic component there, which is basically a ceramic film resistor form, but it doesn't have the resistor coating on it, that is simply to serve as an insulated connection that holds that one lead-in wire, which is supporting the filament, and also a wire that goes down to the starting electrode at the other end of the discharge tube in fixed position relative to that part of the frame which, supports the internal assembly of the lamp. Also, as an expensive, for lamps component, that ceramic former, and then there's another one down in the base. Those are not cheap to make, but very durable. And again, this is an Iwasaki lamp, which are among the best lamps made, especially their Japanese ones. Although the American-made ones they made in Mentor, Ohio, those ain't too shabby either. And there is the lamp on startup. Just peaked up to 1,160 watts or thereabouts. And now it's going back down. That's one thing about self-ballasted or blended mercury lamps, is that their power consumption is actually highest right after startup, because the arc tube is only dropping something on the order of 20 volts or so. And then as it comes up to the full, about 130 volts in the case of this lamp, the power will drop down to about the nominal 750 watts. And there is the lamp, already somewhat warmed up. See, these warm up relatively fast for high pressure mercury lamps because of the extra heat from the ballasting filament. And the lamp has stabilized at about 818 watts. And there's the lamp fully warmed up. One thing of note about these lamps is they do make a bit of a buzzing noise, as you can probably hear, because operating current's on the order of about 3 amperes and change, and magnetic repulsive effects cause bits of the lamp to vibrate internally. But you'll see the same thing in higher power incandescent lamps as well. Definitely once you get up to the 500, 750, 1000, 1500 watt range. And this is a 750 watt lamp, so not surprising. Power has dropped slightly to 810 watts. And it's going back up a bit. Let's see, we should be at 243.2 volts it's running on right now. So even though it says 240 to 250 volts, it's probably more in the order of a 230 to 240 volt lamp, given the slightly higher operating power. And long term it's stabilizing at anywhere from 810 to 816 watts depending on the supply potential. It sometimes dips below 810, but that's about its average for 243 volts.